Hello, Gilles. How are you?
Good, and you?
Good, good. It's the end of the week. It's
Finally.
actually really the end of the week because sometimes we film these things. It's like Wednesday morning, and we say it's the end of the week because that's the name of the podcast. But it's actually 4 p.m. even past 4 p.m. on a Friday. So
The beer is closed.
yeah, it's getting close, getting close. All right. So Gilles, for everyone listening, Gilles is the president of a material handling equipment provider called Structurac. We've worked together for many, many years. Our teams have collaborated. So we solicit the help of different vendors in the industry. As I said, our teams have worked together on numerous projects, very successful and interesting projects. And so we thought that we would invite you on our podcast today to talk about something that is quite specific in the material handling equipment, and that is the norms and the laws surrounding the type of system that you sell to your clients. And for those who think that this sounds boring, well, it's still important to pay attention because it does involve a lot of things and people who need to put systems up, whether it's in existing buildings or new buildings. There's a lot to consider, and it has impacts on people's lives. Obviously, there are huge safety elements. Different jurisdictions will have different norms, but overall, we may talk about some specifics today, but ultimately, we want to help our viewers to kind of think through some of these elements when they're faced with decisions to be made around these large investments in equipment. So I'll let you, first of all, that will be the topic. I kind of skipped,
sure.
though, maybe present yourself so that it gives credibility to what you're going to say.
Yeah. Well, thank you for inviting me.
Yeah.
That's so nice to be here today. Especially, I know there's a beer waiting for me afterwards.
Yes.
And maybe a ping pong game.
Yeah, we could do that too.
Okay. So we're gonna try not to be boring today. Racking is not that glamorous, but we'll try to do something nice.
And just a quick thing on your background, right? You've
Yep.
been doing this for a very long time in different roles. So
Yeah, so I fell in love in that business in 1986. So I'll let you do the math, but it's quite some time. I've studied in civil engineering. I knew I would work in steel, really like working with steel. I just didn't know in what. And I didn't know racking at all. I mean, racking for me was like non-existent. They were not teaching anything about racking or storage system at school back then. So I started in '86 as a young engineer working in design department, and one day I had an opportunity to buy some share of a company, and always been involved. I'm a passionate guy. I'm here because I'm passionate. Always been involved with different committee that defines standards. So I was in the first CSA committee in Toronto back 1990 or 1995, something like that. Then with CNN SISTI here in Quebec, involved with RMI as well. So yeah, just passionate. Still involved today with Carrefour Logistique at the HSC. I'm passionate, trying to hire just passionate people. And I think it's glamorous, in fact.
Good. Well, good. Some people have to think this way, right?
Yeah.
All right. So, yeah, let's get into the topic. So, like, in a nutshell, what do, warehouse managers or people, as I said, that need to put together either to transform, to update, to replace their material handling equipment within the warehouse, whether it's racking or even mobile equipment like reach trucks and that kind of equipment, have to think or be careful not to, and what are the pitfalls that exist that you currently see? Because this is a changing environment, right?
Yeah. It's even difficult for us to follow. There's so many standards now. I mean, when I started, there was no standards in Canada. So we were following the United States standard back then, back in '86. But now there's all sorts of standards. So, let's talk about, let's say, two different type of project. Like the brand new distribution center would be something, and all the other projects that are in existing buildings, or people are just remodeling. So the standards are the same though, whatever it's an old building or a new building. You're not going to have a freebie with the standards because you are in an old existing building.
Mm-hmm.
So when it's a new building, it's pretty straightforward. Almost every engineer is involved in the project, from the concrete slab to the steel structure. Well, they know the new standards and they'll conform to it. Now, we have to conform to it as well for all the equipments that we're selling. And storage systems, well, they need to be designed to resist to seismic event. And this is something pretty new here in this province. So in Quebec, it's part of law. And when I'm saying it's part of law, it's because it's been incorporated to the Quebec National Building Code, which it was not the case forever.
And are you saying that Quebec is the first, or some of the first, or
No.
actually they're lagging?
Yeah, they're lagging.
Okay.
They're one of the last, I'd say. Yeah, Ontario, for instance, or BC. It's a fact for so long
Okay.
that they need to conform. It's part of law. But here, it's only since January 2022.
Okay. And what about the states?
States, it's for quite some time as well that they need to conform. They need to follow RMI, and RMI is asking to design for a seismic event as well.
Okay.
Slowly but surely, Canada and United States are really working hard together to make it more similar, because up to today, the differences are very different in design. It's a complete different approach. So for us, we need to know the standards in Canada. We need to know the standard in the States. While sometimes most manufacturers in the States believe that the standards in Canada are the same as in the States, but it's not the case at all.
Okay.
So going back to Canada, let's finish that portion. So now it's law in Quebec. It's got to be designed to withstand seismic event. And if we were looking at the country, seismic-wise, the worst place to be is on the West Coast, as everybody knows, Vancouver area and all that. But the second worst place is here in Quebec. So there's a fault in the St. Lawrence River, which means that the greater Montreal area is highly at risk. And the second worst place in Canada is Rimouski, in fact.
Oh, really?
So fortunately, not many people are living there.
Yeah.
But it's very severe. So, and since it's severe, and since we're going higher and higher, those racks are taller and taller with more loads. It's transferring those loads to the concrete slab. So it's impossible to install racking without looking at a concrete slab.
Yeah.
So it's part of our mandate to look at that as well when we're working with a customer.
And just doing a side, because that could be a long conversation as well, but just in what you said, meaning that the racking equipment and the slab, the design of the slab and the specs are interrelated, but when you think of a typical project of putting a new building where there is actually a slab to be built and designed, and when you select your equipment vendor, those can happen at very distinct time, right? And I'm sure poses a lot of challenges as well.
Yeah, it's a lot of challenges for us and for you as well, because you're preparing a bid package. You don't know the type of soil. You haven't done the geotechnical study.
Mm-hmm.
Maybe someone did that you don't know, but you're preparing this bid package. You're asking for pricing, but all those pricing could go in another direction once we know the type of soil, because it varies. All those acceleration in case of a seismic event varies by zip code.
It's that granular.
It's that granular. So you go out for bid, you select a vendor, then this vendor can realize afterwards that there's a geotechnical study just being made, saying that soil is type E, which is the worst.
Yeah.
And then suddenly it's affecting how much steel we need to put in our system. It's affecting the concrete slab, could affect a lot of things.
And the amount of steel you put in your system directly affects cost, obviously.
It's really directly proportional. So that's a new world. So now it's law in Quebec. It's law for the rest of the country, and but it's pretty easy when it's a new project.
Mhm.
When it's an existing system, customer is saying, he's hiring you guys. You make the study. You bring down the racking. You put up a new type of racking system, and well, we're supposed to do the same exercise.
Mhm.
So this means that we should ask for someone to do a survey to study the loading capacity of the soil, of the concrete slab, and to do it right.
Mhm.
So it's adding a level of difficulties that people don't know, that people don't put any cost on.
Yeah.
Because they just think that racking is easy. I'm always fighting against that. Like, racking is easy. There's no such thing like racking is easy. To give you an example, at the beginning of my career, it was just calculated with static load. There
Mhm.
was no seismic. Seismic you cannot calculate by hand.
You need advanced tools and
You need
simulation.
advanced tools to do the engineering. So as soon as you're moving a beam up, a beam down, you're changing the whole behavior of the system.
Mhm.
So it's pretty complex. There's no such thing like saying there's easy rack.
And so recent the evolution of the norms are, how are they changing the game, if I could say it this way, or like what do you need to do, or what, again, those that live in those buildings operate need to consider when they know a change is coming, they need to augment their capacity or whatever the reason is.
Yeah.
But they have to think about this and say, I'm going to do some changes, and maybe some of them do think it's simple, as I'll move
Yep.
XYZ, but
Yep.
what should they be thinking about?
Well, basically, I mean, starting hiring you guys is
Oh,
is
yes.
a good,
Once this is done,
is a good
this
first
is
step.
this is obvious, but
Basically, once we know the design, once the vendor has been chosen, then on our side, we're going to tell you exactly all those loads, because seismic is not about just loads that push the concrete slab, but loads that are pulling up the concrete slab. So once we have all those loads, it's a matter of sitting down with a specialist that can test the concrete slab of the customer with the soil underneath, and he's gonna tell us, if it works or if it doesn't work.
Mhm.
If it doesn't work, well, we have a lot of imagination. Sometimes we could put a very long or channel underneath the racking, putting grout underneath that channel to distribute properly the loads to the slab. So that this is something we've done a lot, but sometimes it could be much more difficult than that.
So you're saying there are solutions, but those solutions will add both
Yeah,
cost and
yeah.
time, right? Because sometimes also I mean, there are lead times, obviously, for sourcing
Yep.
the components and
Yep.
to put this in place, and so you can have some bad surprises that can actually change when a project is going
Yes.
live, because some checks were not made in time.
Exactly. So the thing is, once there's a vendor selected, there's kind of a sprint to do, to give those loads to a specialist, to do the test, and to say, okay, we're fine with the concrete slab and the soil, because most of the time it's the soil the problem. It's not really the concrete slab.
Because you could build what you want. Then again, it has a cost depending on the thickness
Yeah.
of that slab, right?
Exactly.
But the soil is driving more of the issues.
I mean, you could build a 12 inches concrete slab on jello.
Yeah.
It's still going to be jello.
Yeah.
So, I mean, that soil is so important. So it's just a matter of doing that. The thing is, it's adding to the length of the project. And that's really the part that people are not aware of.
Mm-hmm. Yeah.
And we had a case recently about that. We were the successful vendor, and then everybody wants to go fast, because like you're saying, there's lead time, 18 weeks to manufacture racking and all that. But I mean, we have to stop from there and say, okay, someone has to look at those loads, and is the concrete slab okay or not? And if not, yeah, there's solutions. Sometimes, again, we have imagination, we can create things, but it's got to be done right.
But those solutions can become cost prohibitive or
Oh,
change the ROI on a project. Or if you don't do it, then you may have a reduced capacity, or ultimately you do not get what was originally designed.
Exactly.
Yeah.
Exactly. And that's why it's important. I mean, if I was going to make you a recommendation, if it's a new project, try to find out right away if there was a geotechnical study. If there was one, they know the type of soil. Just putting this in the tender would help us out a lot, because we would design at least right away we would design at first glance the right way. If not, because I mean, we can look at those tools that we have that can say, okay, in that area it's soil type D, but I mean, soils vary every 10 feet, and then someone did a specific study for that area, and soil is E. It's not the same structure design at all. So if you can get that would be very helpful.
Okay. You were telling me also about sometimes some norms that I'll say depend on the other or have relation with other norms. I think we were talking about racking mobile equipment. Can you elaborate on this?
Yes. Yeah. I mean, this is so funny, because when we do a project, even though we're never going to sell any lift trucks, we need to be pretty good about lift trucks.
Yeah.
Because I mean, we cannot design anything without knowing about lift trucks. So we've always been pretty good and pretty informed with lift trucks. Now the other way around is untrue. The guys selling the lift truck don't know much about racking system. So Canada is looking at this now saying, okay guys, I mean, there's two standards.
And sorry, you say, just to clarify, you say you as racking providers, you need to understand lift truck because it impacts your design. You're saying it on the other side, it's not as true, because the how racking is designed does not impact that much how you design a lift truck, is your point.
Exactly.
Yeah.
That's what everybody was thinking. But you know, there was a case, there was an accident at one point that a lift truck was able to go underneath a very low beam level, something like 96 inches high, and it was an accident because of that. So basically, they were saying, well, you know, the rack was not designed properly. On the other ends, the lift truck provider knew that he was going to do that maneuver. So now, I mean, when you think about that, for Canada to say, you know what, guys, you got to talk together and make sure that it's safe for everyone, makes sense. It just makes sense, and it's just going to force everybody to do it right. But yeah, I mean, all those standards are so complicated, and I mean, it's one is attached to another. So we can talk about, you know, national building code, or in the States or in Canada, that is pointing to a specific standard, and that standard is pointing to another specific standard about how to calculate when it's cold form steel, hot roll section, and then it's sending you to another standard. Even for us internally, you know, we're building documents so our engineers and designers can follow, because it's not easy. So back in 1986 when I started, there was nothing. Now, my God, there's so many standards, and you got to do it right. And it's really to protect people. It's all about that.
And that's why you said earlier in this conversation that there's no such thing as a grandfather clause anymore.
No.
It's in this industry we just cannot allow it because of the safety of people involved.
So let's say that you're an owner of a distribution center. You've bought racking 30 years ago. You kept the racking in good condition, and you have not changed a damn thing, and you have your stamped engineer drawing in hand, you're fine.
Yeah.
As soon as you change something, you got to adapt to the new standards.
And yeah, what are the chances that over a long period of time, maybe much less than 30 years, that a system won't be adapted? Because, I mean, it's a dynamic environment. The size of products, sizes of pallet, whatever, or height of pallet, I should say, will have operators modify to adapt and optimize the capacity. I mean, even the work we do is about, hey, here's how you could change things. So that situation is very rare where you say, well, I have my stamp engineer drawings and here's how my system looks like. So I guess what you're saying is there may be a lot of people that are out of compliance right now.
I'd say about 80%.
Yeah. Yeah, no, it's
because people just don't know, and why I have this opportunity today. I mean, the first reason in North America why operators are getting killed is because they are moving beams around. And as soon as you move a beam up or down, you're changing the whole behavior, and it's killing people. People don't know. I mean, they look at tracking like, there's holes everywhere. I can adjust like I want.
Yeah, it's like Legos or...
Yeah, no, it's killing people. So as soon as you're moving something, you're changing the loading capacity. So...
Have these norms, are we able to see that these norms are actually having an impact or positive impact on?
That's a so good question. So when I started my career, there was various K factor, and K factor is just going up and up, which means it's more severe and more severe. And I'm always giving this example to young engineers we're hiring. So when I started in '86, if you had a regular upright with beams every 48 inches, well, this upright could withstand about 25,000 pounds. That's '86. So they've changed some factor in all those standards. So we're in about mid 90, let's say 93, 95. Well, that 25,000 is suddenly 20. And today that's about 12,000.
You're saying that
the same components. The same components can withstand much less.
Because manufacturers are able to meet the standards with less steel? Or I don't...
No. So let's say we're taking the same components as we had 40 years ago.
Yeah.
Back then, the standards were so much looser, if I can say, compared to today, that we could put more loads in those racks compared to today. So let's say you haven't touched anything, which, like you're saying, it's impossible. So we go in your facility, we do the new calcs, and then we tell you, that's not good.
Okay.
And let's say you were there 40 years ago, so you would say, hey, wait. I've bought the tracking, I've hired engineers, and they told me I could put 2,500 pounds at each pallet location. That was true 40 years ago. Today, that 25 is about 1,500.
Okay.
So because those norms are much more severe, and why they're more severe, my theory about that is people don't do enough maintenance. And all those safety factors are protecting the end user. Because what is really a safety factor? Well, safety factor is every time you hit a structure, since there's safety factors, it's not going to fall instantly. What do? You basically eat a little bit of that reserve every time you hit. And since people are very bad with maintenance, the standards are more and more severe. It's so funny. People are good with maintenance of their trucks on the road, their conveyors, their lift trucks. Racking? I'm asking the question to all my customers. And they don't have that line in their budget, maintenance of racking system.
Yep.
The line doesn't exist. So $1,000 is too expensive.
Yeah.
And that's really the big problem that
Shouldn't there be norms around the need to inspect and...
It is in those standards in Canada and in the USA.
It's hard to control.
You're supposed to inspect. Each end user is supposed to select someone to inspect their structure. So you're supposed to do something internally. You're supposed to be trained to do it with your own staff. But at least every year, you need to hire a specialist to walk around and make sure that it's safe and sound. So this is part of law in North America. Does people do inspection? Not that much.
Yeah.
Not
Okay.
that much.
Well, I think we've covered a lot. Thank you. I hope the viewers will get them thinking and think about their own operation. Before we say bye, I'd like to take a few minutes to change the topic.
Sure.
And talk about steel price volatility, because we do a lot of vendor selection and racking for our clients, and obviously we have benchmarks, we have a lot of historical data, but it's especially with COVID that the past few years, we've seen huge swings, like many other parts of
Yeah.
the industry, right?
Yeah.
But can you speak a little bit about how that price of steel, because well, no, I don't think we've said it here, but the steel in itself is the most is the factor that influences the price of a solution by far, is the greatest component. But how does those steel price fluctuation impact your ability to be competitive and sell storage systems?
Okay, so there's many questions in your question.
Yeah, I know. I was
so-
trying to get a little
so-
something at the end, but tell me about steel prices.
So let's try to be pretty clear and
Let's try to be structured, not all
Yeah.
messy like I just was. Yeah.
So basically, steel is you want to build a distribution center. The structure of the building is steel. The lift trucks is steel. All the equipment is steel. So when those steels are just going to the roof, I mean, it's killing projects. I mean,
Yeah.
it just killed some project for us, or the customer had to change so many things. So it's so interesting because up to about 4 years ago, that was a very stable market. So most of my career, it was stable. We had price lists internally. We could say to our customer that those prices were good for 90 days. So most of my life, it was stable. Since 4 years, it's just crazy. In 4 years, it quadrupled the cost of steel. Fortunately, in our products, there's a lot of there's a lot of I'm searching for main d'oeuvre.
Labor.
Labor. There's so much labor in our product that it's not 4 times the price. It's about 2 times the price.
Still.
But still, and up to today, you know, like I'm looking at this every 2 days, and past few weeks, you know, it's up 3%, and it's always going up, but not as crazy as a year ago, let's say, or 2 years ago, or 3 years ago, but it's very volatile. Which means that we've lost our reflex as well. You know, for so long it was stable, so we had budget numbers that we could reuse. I mean, you would ask me for a budget now. We really have to take a close look at it because it's just so volatile. So let's say you're working on a budget with a customer. You know, I would say, I mean, you're gonna call some vendors, some lift truck guys to get some ideas. And I would say if the project is in a year, you know, add about 10%.
Okay.
Because we're still in there. And the biggest problem is there's less and less steel manufacturer on this planet. The largest ArcelorMittal is basically buying everything. So it's really like the price of gas. You know, there's not many manufacturer making gasoline. So they basically do what they want, and steel is becoming pretty much the same thing. Canada, we make less and less steel. United States is in the same vein, but they're opening up again now. But yeah, I mean, volatility is just crazy. So we have to be very, very, very careful because again, it's not just all the storage systems, lift trucks, structural steel of the building in itself. They're still everywhere in the building. So we sadly in the past few years, you know, some projects were cut down because the customer really wanted that building, and the building suddenly is 20% more expensive to build. And here we are. We were the first one affected. Sadly, we don't see the end of it. And again, I'm studying this basically like the exchange rate with the United States.
Yeah.
Every 2 days, I'm looking at it, and it's always a little bit up. 1%, 2%, 3%, but there's no stability, sadly. So sometimes, you know, we're asking customers, you know, where you got your price? Well, I bought some racking 10 years ago, and no, you cannot use those numbers. So, yeah.
Okay. Well, thanks for those insights. Again, Gilles, I appreciate you coming in. Thank you
Pleasure
very
to be
much.
here.
I think it's time for beer and ping pong.
Woohoo!
Or beer pong. We'll see.
No,
We'll see what's up.
no.
No, we're not that young.
No.
All right.
We're too
Thank you
old for
so
that.
much. All right. Thank you, Gilles.
Thank you.